64,000 is the median number of words per book. Average person reads about 200 words per minute. Simple math will tell us that is one book in 320 minutes. To accomplish this in 7 days, numbers say you would have to read for 45 minutes a day. Don't forget to subscribe. Hit that notification button, like, comment, and share. Enjoy.
Hello, and happy day. How does slowing down sound to you today? Would you like to reduce the noise for just a bit? Are you ready to make a choice and decide to listen? My name is Igor S.F. Walker. I am here to remind people to slow down, to reduce the noise, to walk their lives into a natural flow. Welcome back to the Book of the Week series. Every week, as I read another amazing title, I share it with the world. Today, we look at Reality is Not What It Seems. The Journey to Quantum Gravity by Carlo Rovelli. In this video, we will look at what are the elementary ingredients of the world. Do time and space exist? And what exactly is reality? Theoretical physicist Rovelli has spent his life exploring these questions. We will discover how our understanding of reality has changed over the centuries and how physicists think about the structure of the universe today. What is science? Who are true scientists? And why is any of it reliable to begin with? So stick around till the end, as I will share with you a way to discover some of the secrets hidden inside of yourself, how to discover elementary ingredients inside of you. And I will share a way to find out why you do the things you do. What are the hidden motivators behind the scenes? These innate human needs we're sometimes not even consciously aware of. If we try to put together what we have learned about the physical world in the course of the 20th century, the clues point towards something profoundly different from what we were taught at school. An elementary structure of the world is emerging, generated by a swarm of quantum events where time and space do not exist. Quantum fields draw space, time, matter, and light, exchanging information between one event and another. Reality is a network of granular events. The dynamic which connects them is probabilistic between one event and another. Space, time, matter, and energy melt in a cloud of probability. From time immemorial, or at least since humanity had left written texts, which have come down to us, men have asked themselves how the world had come into being, what it was composed of, how it was ordered, and why natural phenomena occurred. For thousands of years, they had given themselves answers which are all similar. They resembled one another. Answers which referred to elaborate stories of spirits, of deities, of imaginary and mythological creatures, and other similar things, from cuneiform tablets to ancient Chinese texts, from hieroglyphic writings in the pyramids to the myths of the Sioux, from the most ancient Indian texts to the Bible, from African stories to those of Aboriginal Australians. It was all a colorful, but basically quite a monotonous flow of plump serpents and great cows, of irascible, litigious, or kindly deities who create the world by breathing over the abyss, uttering fiat lux. or emerging out of a stone egg. For the Earth, it is necessary to distinguish between forced motion and natural motion. Forced motion is called by a thrust and ends when the thrust ends. Natural motion is vertical, upwards or downwards. And it depends both on the substance and the location. Each substance has a natural place, that is to say, a proper altitude to which it always returns. Earth at the bottom, water a little way above it, air a little higher still, and fire even higher. When you pick up a stone and let it fall, the stone moves downwards because it wants to return to its natural level. The air bubbles in the water, fire in the air, and children's balloons move upwards, seeking their natural place. We must not think of forces acting directly between distant objects, as Newton presumed. We must instead think that there exists an entity diffused throughout space which is modified by electric and magnetic bodies, and which in turn acts upon, pushes and pulls those bodies. This entity, whose existence Faraday intuits, is today called the field. What is then a field? Faraday sees it as a formed by bundles of very thin lines, infinitely thin, which fill space, an invisible, gigantic cobweb filling everything around us. He calls these lines lines of force, because in some way these lines carry the force. They transmit the electric and the magnetic forces from one body to another, as if they were cables pulling and pushing. 20th century physics has radically modified the Newtonian image of the world. The new steps are the basis of a great deal of today's technology. The deepening of our understanding of the world is based on two theories: general relativity and quantum mechanics. Both demand a daring re-evaluation of our conventional ideas about the world, space and time in relativity, matter and energy is in quantum theory. The sharp distinction between fields and particles introduced by Faraday vanishes. The general form of a quantum theory compatible with special relativity is thus called quantum field theory, and it forms the basis of today's particle physics. Particles are quanta of a field, just as photons are quanta of light. All fields display a granular structure in their interactions. During the course of the 20th century, the list of fundamental fields was repeatedly updated. And today we have a theory called the Standard Model of Elementary Particles, which describes almost all we see, with the exception of gravity, in the context of quantum field theory. The development of this model occupied physicists for a good part of the last century, and represents in itself a wonderful adventure of discovery. Einstein showed over a century ago that we cannot separate time and space, that we must think of them together as a single whole, space-time. The moment has come to rectify this and bring time back into the picture. Space, as an amorphous container of things, disappears from physics with quantum gravity. Things, the quanta, do not inhabit space. They dwell one over the other, and space is the fabric of their neighboring relations. As we abandon the idea of space as an inert container, similarly, we must abandon the idea of time as an inert flow along which reality unfurs. Just as the idea of space continuum containing things disappears, so too does the idea of a flowing continuum time during the course of which phenomena happen. Quanta of gravity do not evolve in time. Time just counts their interactions, as evidenced by the Wheeler-DeWitt equation. The fundamental equations no longer contain the time variable. Time emerges like space from the quantum gravitational field. This was already partially true for classical general relativity. Time already appears as an aspect of the gravitational field, but as long as we neglect quantum theory, we can still think of space-time in a rather conventional manner, like the tapestry in which the story of the rest of reality unfolds, even if it is a dynamical, moving tapestry. We must not think of time as if there was a great cosmic clock that marks the life of the universe. We have known for more than a century that we must think of time instead as a localized phenomenon. Every object in the universe has its own time running at a pace determined by the local gravitational field. In reality, we never measure time itself. We always measure the physical variables, A, B, C, oscillations, beats, and many other things, and then compare one variable to another. That is to say, we measure the functions. We can count how many beats per each oscillation, how many oscillation for every tick of a stopwatch, how many ticks of a stopwatch between intervals of the clock on the bell tower. The point is that it is useful to imagine that a variable t exists, the true time which underpins all those movements, even if we cannot measure it directly. What Copernicus, Newton, Einstein, and many others did was to build upon pre-existing theories which synthesized empirical knowledge across vast fields of nature, and to find a way of combining and rethinking them to improve the general picture. This is the basis on which the best research of quantum gravity operates. The origin of knowledge, as always in science, is ultimately empirical. But the data on which quantum gravity is built is not new experiments. It is the theoretical edifices which have already structured our knowledge of the world in forms which are only partly coherent. The experimental data for quantum gravity are general relativity and quantum mechanics. Building on these, trying to understand a world in which both quanta and current space exist may be made coherent, we attempt to look towards the unknown. Dirac gives us encouragement. We do not presume to be of their stature, but we do have the advantage of sitting on their shoulders. And this allows us to look further than they did. One way or another, but we cannot but try. Science is sometimes criticized for pretending to explain everything, for thinking that it has an answer to every question. It is a curious accusation. As every researcher working in every laboratory throughout the world knows, doing science means coming up hard against the limits of your ignorance on a daily basis. The innumerable things which you do not know and cannot do. This is quite different from claiming to know everything. We don't know which particles we might see next year at CERN, or what our next telescope will reveal, or which equations truly describe the world. We do not know how to solve the equations we have. And sometimes we don't understand what they signify. We don't know. If the beautiful theory on which we are working is right, we don't know. We don't know what there is beyond the Big Bang. We don't know how a storm works, or bacteria, or an eye, or a cell in our own bodies, or our thought processes. Scientist is someone who lives in the of the awareness in direct of its own ignorance, in direct contact with our unknowable limits, with the limits of our understanding. Science is not reliable because it provides certainty. It is reliable because it provides us with the best answers we have at present. Science is the most we know so far about the problems confronting us. It is precisely its openness, the fact that it constantly calls current knowledge into question, which guarantees that the answers it offers are the best so far available. If you find better answers, these new answers become science. The answers given by science then are not reliable because they're definitive. They're reliable because they're not definitive. They're reliable because they're the best available today, and they are the best we have because we don't consider them to be definitive, but see them as open to improvement. The world is more extraordinary and profound than any of these fables told by our forefathers. I want to go and see it. To accept uncertainty doesn't detract from our sense of mystery. On the contrary, we are immersed in the mystery and the beauty of the world. The world revealed by quantum gravity is a new and strange one, still full of mystery, but coherent with its simple and clear beauty. And there you have it. Please, do help out. Simply like this video so more people can enjoy it. Share it too and spread the word. Leave a comment and share your thoughts. Subscribe to my channel and stay up to date. And the link to this book is in the description below, so buy it and read. Never stop learning, especially learning about yourself and nature. So gift yourself by taking the free human needs test on my website and find out what actually motivates you. What innate human need is driving all of your decisions and your behavior. And if you feel you are ready to improve your self-awareness, social awareness, self-management, and relationship management even further, do check out my Master of Life Awareness program. The links are in the description below. Thank you. Love and respect.